Okay, so 10.5 is perimeter and area on the coordinate plane. So remember, perimeter is distance around a figure. So this first one says find the perimeter of a pentagon with those vertices. So let's plot those vertices. There's A. B is at 4, 4. C is at 3, negative 2. And D is at negative 1, negative 4. E is at negative 4, 1. So we draw these lines. And there's my pentagon. So remember, perimeter is distance around. Okay. So we need the distance of each of these sides. So AB, BC, CD, DE, and EA. We need the length or the distance of each one of these sides. So AB is easy because it's a horizontal line. So the distance is 5. B, I have to count down 1, 2, 3, 4, 5, 6 over 1. So BC is 6 plus 1, which is the square root of 37. CD, down 2 over 1, 2, 3, 4. Which is the square root, and you could just put this in your calculator. I just don't happen to have a calculator right here with me, and do the square root of 2 squared plus 4 squared, and get your decimal. I have to do it in 2 steps. So D is for DE. I'm going to go over 1, 2, 3, and up 1, 2, 3, 4, 5. So 5 squared plus 3 squared is the square root of 34. And then EA is up 1, 2, 3, 1, 2, 3. So the square root of 3 squared plus 3 squared. Square root of 18. Alright, so now we're going to add all those together. Alright, so I have 5 plus 6.08 plus the square root of 20 is 4.5 plus the square root of 34 is 5.8. The square root of 18 is 4.24. So I get, let's see, plus 6.0. If I add all those together, I get about 24.8. That's the perimeter around. And so we've We've done this a lot, and you should know distance. Finding areas of figures on the coordinate plane. So here's the three. Now the first one, you know, area of a triangle, 1/2 base times height. You know, a rectangle, base times height. And a parallelogram is the same. The thing I want you to see here is that height, the h, is always perpendicular to the base. So we look at these first three formulas. Look, here's height and base, perpendicular. Height and base, perpendicular. Height and base, perpendicular. And so that's the key on these. A right triangle, base and height, is still perpendicular. So that's the difference between the two triangle formulas that you see. Height has to be perpendicular to the base. So your only new ones are the bottom three. A rhombus, which is almost like a triangle, right? You see diagonal, 1/2 diagonal times diagonal. And if you think about it, a rhombus's diagonals are perpendicular, right? So it's almost like that, height and base. Kite, same thing. Diagonals are perpendicular. 1/2 diagonal times diagonal. So those two are the same area formula. And then trapezoid is 1/2 of base plus base times height. So you're doing the average of the bases times height. And again, it's perpendicular. All right, so next page. Find the area of each figure. So we have A is at -4, -2. B is at -2, 2. And the neater you can draw these lines, by the way, I'm not doing a real good job of it because I'm sitting here at home. I can't get my hand too close to the screen or I hit the recording part of it. But the neater you can draw your lines, if you use a straight edge, the better these are going to, easier it's going to be for you guys to see these. And then C is 5-1. See, like right there, that line is so crooked. Okay. So I'm going to use AC as the base. Okay. So I need my height. The height is going to be up to B. But you have to remember that I have to draw, it's got to be, the height has got to be perpendicular to AC. So the slope, I'm going to check the slope of AC here. 1, 2, 3, 4. Well, I've got to find height or length of it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So the slope is up 3 over 9, which is 1/3. So perpendicular slope is going to be -3. So if I start at B and I count down 3, 1, 2, 3 over 1, there is my height. Okay, now I just said, so the distance of my height, I just said it was down 3 over 1, which is the square root of 10 which is about 3 point, I think, maybe 1. I'm guessing here. Hang on, we can do it. The square root of 10 is 3.16, so 3.2. And then the length of my base is the square root of 9 squared plus 3 squared, which is the square root of 81 plus 9, 9.48. So I'm going to call that 9.5. So my area is 1/2 times 3.2 times 9.5. So 9.5 times 3.2 divided by 2 is 15.2. Alright, so this next one we don't have to draw. And we're finding the area. So I need, it's a rectangle, and I can check that. Let's see, here's 2. 1, 2, 3, 4. And here is 1, 2, 3. 1, 2, 3, 4, 5, 6. So my slope is down 3/6, which is negative 1/2. And my blue slope is up 4/2, which is positive 2. Those are opposite reciprocals. So it is definitely a rectangle. So now to find area, the distance of that blue is 4 squared plus 2 squared, which is square root of 20, which is 4.5. And then my purple side, the distance is 3 squared plus 6 squared. Square root of 9 plus 36, 6.7. And the area formula for a rectangle is base times height, so 4.5 times 6.7. 30.2 is the area of that figure. Alright, so find the area of quadrilateral. Let's see, J is -4, -2. I like these a lot better when they already have them on the graph and I don't have to graph them. 2, 1 is K. L is 3, 4. M is -3, 1. That is a strange shape. There we go. Oh, that looks much better. It's a parallelogram. And a parallelogram is base times height. I am going to call this the base. 1, 2, 3, 4, 5, 6. 1, 2, 3. So my slope here is up 3/6, which is 1/2. So my perpendicular slope is going to be -2. So I'm going to start at M and go down 2/1. So the distance of that pink line is down 2 over 1, which is the height. The square root of 5, 2.23. And then the square root, or the base, distance of the base, 6 squared plus 3 squared, is 6.71. And so then area is base times height. And I get times 2.2, 14.6. Okay. All right, so now composite figures. I should have stopped that last one. I had you guys do it and then check back. So composite figures, we got to make different shapes, and it's kind of drawn on here if you can see it. So I need, if I draw these other lines, I figure 1, I'm going to label these 1. Well, let me do it in a different color. 1, 2, 3, 4. If I find the area of each one of those, I'll have the area of all of it. Now 1 is a triangle, so it's 1/2 base times height. And it's easy to count here at least. 1, 2, 3, 4, 5 is my base. And 2 is my height. So 1/2 of 10 is 5. Shape 2, same thing. It's a triangle, 1/2 base times height. So the base is 1, 2, 3. And the height is 2. 3 is a triangle, same thing, 1/2 base times height. So I have 2 and 1, 2, 3, 4, which is 4. And then my last shape is a rectangle, so base times height. The base is 1, 2, 3, 4, 5, 6. The height is 1, 2, 3, 4. Now it doesn't matter which one you call the base and the height because it's multiplication. Order doesn't matter. Now if I add all those together, my area for this composite figure, composite means a bunch of things put together. So I have 8, 9, 10, 11, 12, 36. Now, let's see here. Let's do this one. So sometimes the hardest part is figuring out where to draw your lines. So this one, you almost might want to start by drawing it here, and that's not going to make this the easiest thing to do. The easiest way to do this is going to be that way. Now, you can also, if you wanted, you could do it this way. And then you have 2 triangles where you don't have to do distance for. You don't have to find I just think they're easier. You don't have to find it. If you left it here, it's a parallelogram, and you could do that. Well, that one's not bad either. You just have to find the distance of SR. So let's do this. And I'm going to label these 1, 2, 3. But I'm going to start on 3 because 3 is the easy. 3, 2, and 3 are the easiest. So 1/2 base times height. The base is 2 or height is 2, doesn't matter. 1, 2, 3, 4, 5, 6. So that gives me 6. And look at number 2, shape 2 is the same thing. 6 and 2. And then number 1, I have to find the length. So the height, I'm going to call over 1, 1, 2, 3. So the square root of 10, 3.2, wasn't it? Yeah. And the base is 1, 2, 3, 4, 5, 6, 1, 2. So that's the square root of 40. So 6.3. So the area is 1/2 base times height. So 1/2 of 3.2 times 6.3. Times 3.2 divided by 2, 10.08. Alright, so we'll call that 10.1. Now I'm not going to add these because these just used to find area. So my area is just 6 plus 6 plus 10.1. So 12, that is 22.1 for the area of that figure. Let's see, do we have any examples? Yeah, 1, 2, 3 more. Find the area of the polygon by addition. So that means we're going to add up all the figures. So I'm going to make figure 1, figure 2, figure 3, figure 4. Now pause this and see if you can do these. Let me get you started though with number 1. So 1 is a triangle, so base times height, but I need you to understand the height is right here. So the base is 1, 2, 3, 4, and the height is 1, 2, 3. Gives me 6. All right, so pause it and do the rest of those figures. Okay, so there I have all of them with an area of 34. So pause this and check your answers and see how well you did on that. So number 7, it says find the area of the polygon by subtraction. And what they mean here is you can always do it this way. You can draw yourself a big figure. Okay, the last one we added all of them up. Now this one, we're going to find the area of those 4 shapes and subtract it from the big rectangle that I drew. So the big rectangle, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area of the big 7 times 9 is 63. Now I'm going to subtract each one of these. So number 1, it's a triangle. 1/2 base times 1, 2, 3, 4, 5, which is 5. Number 2, also a triangle, so 1/2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1/2 of 25 is 12.5. Number 3, 1, 2, 3, 4, 1, 2, 3, 4. So 1/2 of 16 is 8. And number 4, 1/2 of 1, 2, 3, 1, 2, 3. 1/2 of 9 is 4.5. So if I subtract all these, 63 minus all of these, my total area will be 63 minus let's see here, what was that? Minus 13. 33. And sometimes that's the easier way to do that. All right, so Miguel's planning on and costing an ornamental garden in the shape of an irregular octagon. Each unit on the coordinate grid represents 1 yard. He wants to lay the whole garden with turf, which costs $3.25 per square yard, and surround it with a border of decorative stones, which costs $7.95 per yard. What's the total cost of the turf and stone? Well, I'm going to draw my shapes because I need. Now, surrounded with a border of decorative stones is perimeter. So we also need perimeter. So I'm going to label these. That's how I saw the shapes. So let's do the area first. So shape 1, 1, 2, 1, 2, 3, 4, 5. 1/2 of 2 times 5 is 5. Number 2 is 2 times 5. 1, 2, 3, 4, 5, which is 10. Shape 3. Okay, so the base, the height 1, 2, 3, and the base 1, 2, 3, 4. So 1/2 times 3 times 4 is 6. Number 4 is 1/2 times 2 times 5. And 5 is the only one that I don't have an actual length for, so I have to use distance formula. Let's do it down here. 1, 2, 1, 2, 3, 4, 5. This one is 1, 2, 1, 2, 3, 4, 5. At least it's a square. So the distance of those sides are 5 squared plus 2 squared, which is the square root of 29, which is 5.4. So that square is 5.4 times 5.4, which is 29, I'm going to call it 0.2. All right, so we add all these up. 29.2 plus 26 equals 55.2. Now, each one of those represents 1 yard, and he wants to lay the whole thing with turf, which costs $3.25 per square yard. So I got to multiply that by $3.25 times $3.25, which is going to cost $179.40. Now we have to do perimeter. Okay. So perimeter 2, that's a 2, that's easy enough. We already know that this side is 5.4, and this side is 5.4, and this side is 5.4. This side is 2. Okay, that just leaves me a couple other sides to do. So 1, 2, 1, 2, 3, 4, 5. Again, that one's 5.4. Well, that makes it easy. And then this one is 1, 2, 3, 1, 2. So distance is 3 squared plus 2 squared, which is the square root of 13, 3.6. So this is 3.6, and this is 3.6. There, I have all my sides done in pink. So if we add up all of them, I'm going to start right here at 2. 2 and 3.6, 3.6, 5.4, 5.4, 5.4, 2. And you know what? I need to write that 2 like that. 5.4, and there I'm done. So if we add all those up, 3.2 plus 3.6 plus 3.6 plus 5.4 plus 5.4 plus 5.4 plus 2 plus 5.4. Okay, I got 32.94. Oh, I messed up something. 7. All right, we're just going to call it 33. And I hit my calculator wrong, but I don't care. We're just going to call it 33. And then surround it with a border of decorative stone, which costs $7.95. So 33 times $7.95 is $262.35. So the cost of this would be $262.35 plus 179.4, 13, 14, 3, 4, $441.75. Okay, a lot of work, but there it is. I think that is okay, yeah, that's the last example. So now you can start on your homework and be good.